And good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Ceramic Solutions for Energy and Water. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Edith Cowan University, ECU. The School of Engineering at ECU is recognised internationally for its excellent quality of education and research, underpinned by highly committed and supportive academics and outstanding infrastructure and facilities. ECU teaches the next generation of engineers to reflect on environmental considerations in their design and development practices and endeavour to harmonise the natural and built environments such that they can sustain and improve our world for future generations. We thank ECU for their continued support. Now, in our session today, we will hear from Paulo de Souza, followed by a panel discussion and then our audience Q&A session. So I encourage you all to please get involved and to prepare any questions that you may wish to ask our panel during the Q&A section. I'd now like to welcome our first speaker, Professor Paulo de Souza. Professor Paulo de Souza is a visionary leader and researcher with global experience across academia, industry and space science. Currently serving as the Executive Dean at Edith Cowan University, he has held senior roles at Griffith University, CSIRO and NASA. Paulo is passionate about translating science into real-world impact, having co-authored 60-plus papers and received multiple NASA Achievement Awards. Please join me to welcome Professor Paulo de Souza.
Thank you very much, Meg. It's really great to be here today. And I think for me, it's about setting the scene and what are we going to talk today and why it's so important to partner with organizations like Fraunhofer. Australia has been extraordinary in publishing. So we have innovation systems, universities, CSIRO, and many other organizations that are able to publish a lot. But we come in the bottom of the ladder when it comes to transfer that knowledge into real-world applications, helping our businesses, helping our industry to innovate, helping us to evolve our economy. This is not happening really well here in Australia. And if there is one organization out there that can do this really, really well, one of them is Fraunhofer. It's an outstanding organization in Germany. It has a budget above €3 billion a year and hosts 76 institutes. And we are partnering with one of them, with Fraunhofer IKTS. And we're going to speak today. We're going to have some demonstration of the kind of technologies they're bringing here to Australia. And that partnerships is a joint lab that we're going to have inaugurated next year. Fraunhofer is going to have a presence here in WA to have a conversation about what keeps you awake at night, what kind of problems you have in your company that we could sit down, discuss, and then bring the best in innovation, but also the best in transferring technology into real-world solutions. This is what this group is able to do. So it's quite strategic for us to partner with organizations like Fraunhofer here in Australia to bridge the gap between the knowledge that we have, the technologies that are out there, to solve the challenges that your business is facing. In that process, being at the university, certainly offering the opportunity for our students to travel to Germany, to have that experience there, to work with your problems right here, right now. So for us, it's everything. It's about the problems you're facing, what's keeping you awake at night, and how can we help through this wonderful relationship that we commenced with Fraunhofer. So this is an example of that, is to bring some of the developments and the cutting edge technologies that we have in ceramics and have then a conversation about that. That's what I have to say today. Thank you very much, Megan.
Awesome. Thanks, Paolo. Well, now I'll go, what I'll do next is welcome our panelists for today. So please join me in welcoming our first panelist, Dr. Matthias Jahn. Matthias is an accomplished leader in energy and process engineering, currently leading a department at Fraunhofer IKTS and serving as a lecturer at Dresden University of Technology with a lecture on electrolysis, fuel cells, and hydrogen applications. He holds a doctorate in energy and chemical engineering from Technical University Berlin and is dedicated to advancing sustainable energy technologies and applied research. Our second panelist for today is Dr. Gregor Herz. Gregor is a leading expert at Fraunhofer Institute, specializing in advanced materials and innovative technologies. With extensive experience in research and development, he focuses on bridging scientific breakthroughs with practical industrial applications. Gregor's work drives sustainable solutions and cutting-edge innovations that address current technological challenges. And our third panelist is Dr. Masmouh Zargar. Masmouh is a senior lecturer and Art Deco Fellow at Edith Cowan University, specializing in chemical engineering and sustainable environmental solutions. She leads the Advanced Materials and Membranes Research Group, focusing on membrane technologies and functional materials for water treatment, mineral processing, and emerging pollutants removal. Please join me in welcoming Dr. Masmouh Zargar. So we'll have all our panelists come together with Paolo, obviously. And what I might do is kick off the panel discussion with yourself, Paolo. So I know you've given a brief introduction, but I suppose, you know, from your point of view, a high-level overview of ECU and Fraunhofer's IKTS collaboration. And I suppose, what does this new lab aim to achieve for Australian industry and research?
Thank you. I think the first point is that we want to listen to problems that the industry is facing. And some of them are quite big problems. It could be in the energy transition, it could be in electrification, decarbonization of economy, or even in some filtration systems, or what you need to do and how to take the most of the assets that we have today in industry. Those are the challenges that keep us motivated and that we want to work towards solutions at the pace that the industry needs. It's very easy to go to universities and then engage in conversations with academics, and they will say, okay, I can help, but I will bring a PhD student. Maybe we can have a couple of PhD student scholarships. And that would put the whole time frame for a solution to 3-4 years, if there is a solution at the end of that process. So for us, it's at the pace that you need. You might need an answer in 3 months, in 4 months. You can't wait. I want to run a quick test. I want to test this technology. I want to know what kind of solutions can I try out there. Can I have an IP landscape analysis? Can I have some understanding of the roadmap in the technology? And this is what this collaboration would enable us to do. It's to answer questions that keeps the industry awake at night, but that will keep the industry awake at night, and we will have a time frame and a quick time frame that you need that answer. So we want to be part of that solution at that pace. So it's a different way to engage, and that is not happening by accident. It's because it's really part of that engagement with Fraunhofer that makes it clear that we need to start shifting the gear on when we're going to work with solving problems. For us here, reading all the industry that we have in WA and also in Australia, we think that technologies like the ceramic filtration systems that we are going to talk today, it's one of them, but there are other things like high temperature electrolyzers that we bring in here, and coupling that with renewables that would enable us then to bring the energy efficiency of those systems and produce energy in a much cheaper way. And I think there is a lot of technology gaps yet to make it viable, economically viable at the industry scale. And also non-destructive testing. That's the other thing. There are some innovative technologies out there in Germany that we bring in here to WA that can make a revolution in the way that we do our non-destructive testing in the field, get information that with quality quickly, and keeping systems monitoring our assets out there. At the same time, offering development, seminars and conversations like this one that will enable us to understand better technologies that are available there. Thank you, Megan.
Thank you. Well, I'm interested to know, Masme, what makes Western Australia a strategic location for launching the Ceramic Technology Hub?
Okay, thank you for the question, Megan. So Western Australia is very unique in terms of access to like the different industry that are present. The demand is there, and then it sits in the intersection of large scale demand and harsh operating conditions that many of these industries are dealing with. And rapid adaptation opportunities, basically. So the state has lots of mining operations, like mineral operations, which are among the largest in the world, and many of them generate high TDS, abrasive, chemically resistant, and chemically aggressive waters that ceramic membranes can easily deal with. So WA is also a leader in hydrogen development, technology development, as well as like renewable energy, as Paolo mentioned. And in terms of the water, and we state that are reliant on recycling and as well as like desalination for the providing sustainable water, treated water, basically. And ceramic membranes can offer great solutions, basically for the reliability of the process, as well as like low maintenance treatment options for all of these kind of industries. Basically, the combination of all these industrial scale challenges that are present at the driving distance, that we can easily pilot things, test the real samples, and then provide fast solutions to the industry, basically. And the proximity to Asia is also another strategic opportunity. But any technology that can be developed here can be also adapted to other Australian states and can be used. Basically, our facility can be available for shared benefits of the whole Australia. Thank you, Megan.
Awesome. Thank you. Matthias, just to bring you in, I'm really interested if you could just take us through the fundamentals of ceramic technology, so particularly the solid oxide, electrolysis technology, and ceramic membranes, and I suppose also their industrial significance.
Yes, thank you very much for the question. Yes, in principle, ceramic materials, they have the advantage that they are very stable under harsh conditions and also at high temperatures. And especially at our institute, we have developed solid oxide cells. And these cells can be operated as fuel cells, but also as electrolyzer cells. So this is one advantage, and also interesting for the application. And these cells, they consist of a ceramic electrolyte. This is zirconia oxide, normally doped with yttrium. And yes, this material has a very high conductivity for oxygen ions, but at very high temperatures. So the advantage is that you don't have the it's no electric conductivity and conductivity for these oxygen ions. This is necessary for the function of these materials and these cells. And the cells has a voltage of about 1 volt. And to get higher voltages, these cells are connected in series. So we build stacks out of these using these cells. And these stacks will then be used to build systems for electrolyzing, also for PTX applications, to produce other things like fuels and so on can be used, or methane, for example. And also we are developing fuel cell systems. So this is also one thing that we are doing, or a research topic in my department is the system development to bring this basic knowledge of materials into real-world applications. So we also develop systems that are operated in the field, for example, to produce heat and electricity at a wastewater treatment plant, for example. So the possibility to operate these cells under harsh conditions with different fuels and at high temperature, this is really an advantage of our system development, what we are doing. And this is also relevant for these ceramic membranes, because these membranes can also be used under very harsh conditions.
Thank you. So, Masame, what differentiates the ceramic materials from traditional technologies in terms of durability, stability, and performance in harsh industrial environments?
Okay, thanks, Megan, for the question. So, ceramic membranes have, and ceramic materials basically have some fundamental differences compared to polymeric or metallic materials that are being traditionally used for membrane filtration and so on. So ceramics, as also Matthias mentioned, can withstand in hard operational conditions. Like they can withstand the full pH range of 0 to 14. We know that in many mining operations, we have very caustic outputs that we need to treat, like for red mud treatment, or in many other cleaning or process conditions, we need a range of pH stability that is not accessible, for example, with polymeric membranes. So polymeric membranes normally fail within a harsh range of above 9, for example. And they can also withstand large high oxidation materials like ozone, chlorine, and so on. And as Matthias also mentioned, they can withstand high temperatures, well above 100. So with polymerics, polymeric membranes, we know that when we increase the temperature above 80, normally the membrane fails or the lifetime will significantly reduce. So this is a great advantage for ceramic membranes that can be operated in very high temperatures, as well as if we have a significant drop or increase in temperature that might occur in many of the processes, ceramics can also withstand those sudden basically changes. They don't crack or they don't fail. In many industries, we have lots of slurries. We have lots of organic matter or different turbidity in the water that we need to have mix to withstand those abrasion of those solids or slurries. So basically, they have a higher structural stability as well to maintain the pressure at different high temperature and pressures. If we want to compare them in terms of the life cycle, like with polymeric membranes, we normally need to change them every 3 to 5 years. But with ceramic membranes, the life cycle of them would be between 10 to 15 years, and it's huge compared in terms of the comparison, in terms of the operational costs. Normally we have lower downtime, we have lower maintenance, and basically a more resistant and reliable process to rely on in the long run when we are talking about ceramic membranes. And they cannot easily fail because we can clean the systems under harsh conditions, which quickly returns the process to the optimized level, while with polymeric membranes, we cannot do that. And the other thing, for example, with metallic filtration processes, we have the problem with corrosion, which we don't have with ceramics as well. So lots of opportunities there. They need to be adopted more widely, basically. Thank you.
Excellent. Thank you. Thanks. Gregor, I'll bring you into the conversation. So how do ceramic components contribute to improved system integration, particularly with regards to processes like circular water management and hydrogen production?
Thanks, Megan. I'll use the high temperature electrolysis that Paulo mentioned as an example, if I may. High temperature electrolysis inherently has a higher efficiency, which does drive economic viability because roughly 70% of the production cost of hydrogen are the energy base. In addition, you can also convert CO2 in a high temperature electrolysis to CO, and then you obtain a syngas, which you can use for downstream processing. For example, if you want to go towards fuels, which in essence works out to a difference in efficiency of about 10 percentage points compared to low temperature electrolysis. And if we keep in mind that energy is the cost driver for production, that makes a big difference for the end user. And in addition, we also have a much higher tolerance towards the contamination of our feed water because it is evaporated and most of the contaminants remain in a brine that can be disposed of. So compare that to a PEM electrolysis where you need a completely deionized water stream. It makes it much more viable for Australia, where most of the water is derived from desalination. So again, that is a big cost factor that is not incurred by high temperature electrolysis. If you couple all that with the possibilities of ceramic technologies for water management, we can have a much more streamlined process. It makes the entire hydrogen economy more viable for Australia.
Thanks, Gregor. I thought I'd like to ask the panel, and maybe to start with you, Masame, with regards to just some examples or some case studies where ceramic technologies have been potentially piloted or actually implemented successfully, be it in mining, water treatment, or the energy sector. So maybe, Masame, if you want to kick off, and then potentially Gregor or Matis to then, I suppose, have any overseas examples?
Yes, sure. Thank you for the question. Ceramic membranes have very high relevance to Australian market because of the diverse industries that we have across Australia. So we have very limited pilots in Australia, but similar technologies like filter, like pressing, have been used. For example, and piloted in red mud separation and caustic recovery of that. For example, in WA and in Queensland, in some water utilities across states, like for example in Perth and also in Sydney, Adelaide, they have been used as pre-treatment for water recycling, in very large scale, but they have been trialed and piloted and currently tried and tested. So, and in energy, it has lots of opportunities as well, like solid oxide electrolyzers aligned with hydrogen hubs in WA and Queensland and also South Australia. There are lots of basically markets and lots of avenues for implementation, but we need more work on that, as Paula also mentioned. So perhaps Gregor can follow us through a couple of, or like a significant example that they have in IKTS that they have adopted and piloted. I think they have a good example to provide, which is analogous to what we have in Australia, basically.
Awesome. Gregor?
Thanks, Masame. I'd like to share some details on one project we had in Canada. It was a cooperation with Shell. They were having trouble with the water management in oil sand mining. They had changed legislation, which essentially prohibited the discharge of the water. The water was contaminated with large amounts of sediments, tars, and ions, quite caustic as well. So the only viable option was ceramic membranes as treatment. So IKTS developed the ceramic membranes. That was a big innovation. It has 161 channels per module. That is an order of magnitude larger compared to previous products. And then based on these membranes, there was a filtration system developed, which separated the droplets and particles and had a partial desalination in a one-step process. So instead of going for two separate steps, because the ceramic membranes are so resistant to abrasion, the entire upgrading process was done in one step. So we built with a partner a demonstration plant which cleaned about 10 cubic meters of water an hour. It was operated for 2 years at the mine and is to this day the largest ceramic nanofiltration plant. And what we saw at the end is that we had no downtime essentially due to failures. It was just it was a research project, and of course you take a stock of what you have every once in a while, but we didn't have any unplanned failures. And we had a complete removal of particles and a removal of between 55 and 80% of all ions. And at the end of the 2-year run, we did not see any damage to the filter layer. So in our view, this qualifies the technology for large-scale operation in a mining environment.
Thanks, Gregor. Paulo, I'm really interested in terms of bridging the research and with industry. How does the lab plan to involve Australian companies in early adoption or co-development of these solutions?
Yeah, I think it's a fascinating question. What we like is conversation. So we sit down and talk to industry, understand the problems that you're facing, understand some of the solutions that you're looking for, try to dimension, looking at the whole spectrum of the solution that would include costs, would include all the supply chain. And for example, in the case of ceramics, IKTS manufactured them. You don't need to buy from somewhere else. You have them manufacturing. And an outstanding quality control on those ceramics tailored to the solution that you are looking for. So that is an incredible capability of 400 engineers and scientists working together with ceramics and manufacturing them in-house for all sorts of solutions like the one that Gregor just said about the one in Canada, or developing new parts of what would be high temperature electrolyzers, of batteries, or filtration systems. It's really outstanding. At the same time, companies sometimes come and say, hey, can you deliver a course for us so you can better understand how this technology works? What are the front end of the knowledge in ceramics? What is the state of the art? And what are the do's and don'ts? How should I not use ceramic membranes to solve some of the problems that I have? So there is a number of alternatives for us, but the best way is just get in contact. Let's talk about some of the challenges you're facing and some of the curiosities sometimes. It's great to have a coffee and talk, or just to have a phone conversation and just understand some of the challenges you're facing. So I think the key solution is to talk, is to understand, and then see if there is any opportunity to solve some of the problems that you have.
Sounds good. Matthias, I'll just ask the next question of yourself. Solid oxide electrolysis cells, SOECs, I think that is how it's pronounced, have been highlighted as a key enabler for green hydrogen. Can you explain their working principles and why they're promising for Australia's hydrogen economy?
Yes, so thank you very much. This is really an important question. So you might ask, why do we want to do research on solid oxide electrolysis cells, especially in Australia, in Western Australia? What are the reasons for this? And this technology can really play an important role, especially also in Australia, because these solid oxide cells, they are operated at high temperature, which means 650 to 800 or 900 degrees C. And you don't use liquid water, you use water vapor. So you need to produce steam. And therefore you can use solar heat or wherever heat is available. So you can couple this process with other processes where you use the hydrogen, what you are producing, and where you have heat available. This is important because then you get this high efficiency, but because you use the heat for the vaporization step. So this is an interesting advantage to use solar heat in Western Australia. And the other advantage, what I see, is you can operate these cells and stacks in the reverse mode. So you can use it for hydrogen production, but also for the utilization of hydrogen to produce heat and electricity. And especially in isolated grids, you have only one system to produce hydrogen, to store the energy from renewables, and then to use the hydrogen again to re-electrification and to produce heat and electricity. So for this, that's why this technology can play a role in the energy transition, especially, for example, in these isolated grids, and also for industrial processes like, for example, direct reduction of iron ore in the mining sector. There, the SOEC is a very efficient option for the production of hydrogen, what you need for the reduction of iron ore. So that's why I believe that the solid oxide technology can play a role in hydrogen economy in Australia.
Australia. Yeah, thank you. So, Gregor, from that, so what role do ceramic technologies play in increasing the efficiency and sustainability of hydrogen generation and storage systems?
Thanks, Megan. To answer that question, we have to have a look at what drives the environmental impact on hydrogen generation. And as for one point, it's the energy generation. So we have resources and land usage for solar farms or wind farms. If you have a more efficient process, we need less energy. So we minimize the environmental impact from the energy source. And additionally, we also have a high environmental impact from the electrolyzers themselves, especially for PEM electrolyzers. They use a lot of platinum and iridium, and these precious metals need to be mined, and this has a huge environmental impact as well. In high temperature electrolyzers, we don't use any precious metals at all. The most impact is the nickel mesh we use as a cathode, which is less of an impact compared to low temperature electrolyzers. So on both the system itself and the operation, we have a lower impact on the environment, and of course, this drives sustainability for these ceramic technologies.
Thanks, Gregor. Paolo, I'm just interested, I know you spoke about the role of the lab, but I suppose beyond that R&D role, how do you see the lab contributing to the actual skills development and capacity building in Australia's research and industrial workforce?
Yeah, we have PhD students that will be allocated to the lab, so they will be working there and they will be devoted to problems that you might come up and say, hey, I would like to develop a solution for this specific problem. The other part is to see small to medium enterprises interested in some of these technologies to be part of their portfolio when they work with large corporations and they provide them the service and the tools for those companies to operate. So that tech transfer is something that Fraunhofer does really well. And if we make that happen, that will be fantastic. So that part of the transfer of technology means that we need also to educate, we need also to be open about the technology that we have and how that is going to be efficiently being used by companies out there. So we don't think that the solution should be just between the lab itself and an industry partner. Sometimes we need to bring other players that will be part of the solution. Innovation is a contact sport. So the more that we bring into, the better. And I think that is really essential for success. When I worked for industry before, and we always have to develop a solution, we try to find a small to medium enterprise that will take that piece of technology and implement whatever we have seen in the lab scale into a pilot plant or even in our own process. That requires a little bit more than just academics here trying to find a solution, but is somebody that really understands what it takes to develop industrial projects and industrial facilities that will be part of the infrastructure and will be part of more efficient processes, cost-effective processes, and probably delivering then what the industry is in need to be more competitive. One final point is that maybe industry wants to learn more about it and maybe come to us and say, hey, can you deliver a course for us about this technology? We would be more than happy to do that as well.
Definitely. So Massimo, how can students and I suppose researchers and industry professionals actually get involved with this or really to benefit from the on-site training and demonstrations and all the things that are generated from the lab?
Thank you, Megan. I think Paulo answered most of this question, but like it's basically a lab which provides hands-on engagement space for everyone. As Paulo mentioned, like we have plans for PhD and master students, as well as like undergrads to like get hands-on experience with the systems that we're developing in the shared lab. They can gain real experience with the systems. So industry professionals also, there will be opportunities for training, like live demonstrations. We had some like webinars and workshops in the past on this joint effort, and we will have more in the future, which would be available to industry professionals and anyone who wants to learn and use this kind of technology. There would be tailored trials if any industry is interested, like to have their samples tested under real conditions with the pilots that are established and in the process of like finalizing the lab. And they can use all of these to de-risk basically their adaptation of the technology to their system. So it's a great opportunity to and a great pathway basically to engage and benefit from a shared lab and shared space for both academics as well as industry practitioners to adapt this technology to Australian markets. Thank you.
Awesome.
If
Thank
anyone
you.
wants to add anything more, welcome. Thank you.
So, Matthias, looking ahead, what innovations or breakthroughs do you foresee in ceramic technologies over the next 5 years? And maybe this question could actually go out to a few more of you on the panel, I suppose. And how do you feel that they may shape Australia's decarbonisation and industrial goals? So we'll kick off with yourself.
Yeah. So thank you very much for this question, because this is really the mission of Fraunhofer, to do technology transfer and to bring fundamental research results into real world applications. So we have already discussed about one example, that was the electrolyzer cells, and now ThyssenKrupp Nucera, they're working now on the commercialization together with our institute to bring these stacks and cells and in complete systems on the market. So this is one example of an innovation that is now going the way from the lab to pilot plants and then to industrial application. And the other example is also interesting, especially for Australia, because we have a cooperation with the company Altech from Australia. It's an Australian company, and we are developing together with them sodium batteries for stationary applications. And this can also play an important role in the energy transition, because you need, if you want to use high amounts of renewables, you need storage options that can be could be hydrogen as a chemical storage opportunity, but also batteries. And these sodium batteries, high temperature batteries, which are also very stable and can be used for longer term storage than compared to example to lithium ion batteries. And this can also play a role in the next years and can be the next technology transfer to the industry. And I imagine there could be also an interesting market for this product worldwide and also in Australia.
Thank you. Did anyone else want to chip in with their thoughts?
I think it would be fascinating when we see ceramics instrumented, making measurements in the process, being part of your monitoring of processes, having catalysts embedded into the ceramics. And I think that smart ceramics is just a matter of time. And there are a number of ways that could be eventually done. And that brings a multidisciplinary team to work on not only in ceramics, but microsensing, catalysts, and many other areas. I think the trend is to see them becoming smarter and becoming more efficient. and adapting sometimes perhaps with the process depending on what we have. So the future is quite exciting of what this area is going to bring.
Awesome. Thank you. Well, look, it's now our audience's turn to get involved with regards to the discussion. So I can see we've had some live questions come through. So please, if you have a question, now's the time to pose it. A big thank you to everyone who submitted questions while registering for the webinar today. So I do have a couple of those questions that I would like to ask the panel, and we'll kick off with one of those. Matthias, the questions come through from Araj from South Australia. So it is, how do ceramic materials compare to other materials in terms of sustainability and long-term performance in energy storage and water filtration applications? Very long question, that one. There is a second part to it, which is, are there any recent innovations in ceramic solutions that significantly improve efficiency or reduce environmental impact? Let me know if you want me to start with that first question.
So, thanks for this question. I already mentioned before this question before the sodium batteries, and this is really one example for energy storage, where you don't need lithium, and you can store efficiently electric energy from renewables there. And I also see in long-term stability, what also was mentioned, the water filtration application of ceramic membranes, what are also important, because also when you want to clean these ceramic membranes, you can use high temperatures and they are very stable, and this is an advantage compared to these polymer membranes. So I see, especially in this long-term performance, advantages of these ceramic materials in these two applications.
Thank you. Massime, a question's come through from Sebastian, who is in New South Wales. So hello, Sebastian. The question is there a benefit of these products for use in the irrigation water sector, that is large industrialized size water purposes?
Yes, thanks for the question, Sebastian. So the short answer is yes, there is definitely opportunity for irrigation water. So we know that irrigation water quality is very dynamic, like it's not consistent, and like it comes from, like the source basically shifts from surface dams to bores to recycled water and so on. And lots of seasonal events can also influence the quality of the source, like rain, algal bloom, like we have spike sediments runoff and so on. So the quality is very dynamic, we know that. And we know that with polymeric membranes, it's a huge challenge, as also mentioned in some other questions that I see on YouTube. So to maintain a consistent output in like basically irrigation systems, it's great to use ceramic membranes, despite the turbidity spikes or the salinity shifts and so on, and also the abrasive nature of the particles that can end up in the influent of the membranes. We can operate the system currently, and the system can be aggressively cleaned as well if something happens, or if any clogging happens, which is not the case for polymeric membranes. Over the large and long service life of the ceramic membranes, basically this means fewer disruptions, predictable costs, and predictable basically outcomes for the sustainability of the process. And I see lots of opportunities in that respect too. Yes, thank you.
Thank you. Gregor Shmindra has sent through a question. He's watching live, so hello. We're using ceramic lined slurry spools in the mining industry. What are the better ceramic types for wear resistance for this application?
Thanks, Megan. That's a very broad question, and I probably have to defer to our colleagues here. It really depends on what your slurry looks like, chemical composition, and the abrasive elements. We do in-house have the entire, let's say, value chain from materials to demo scale applications. So if you want to get in touch with the colleagues and have a joint think about what the application is, what your system looks like, and then we could probably have a clearer picture and give you this answer in detail, if you don't mind.
Not a problem. There was a question which came through, and let me just, where am I? Oh, it was one from Gregor again. Sorry, I'll keep you chatting. It came in from Sabrina from Victoria, and it was, how does ceramic work in tertiary treatment for a wastewater treatment plant? Is that the correct word?
Yeah. So currently we're heavily involved in water treatment in Europe because we have a change in legislation. I believe it's in Australia. There's something on the horizon as well. Currently, the trend in Europe is ozone treatment and or adsorption on active carbon. Of course, with the downside of lots of consumables. So IKT is currently working on next-gen processes using nanofiltration and membranes and maybe photocatalysis. But the application really heavily depends on the contaminants and the legislation. And as you all know, the contaminants really depend whether it's industrial or communal wastewater, and then what the community looks like. So there's no one-fits-all answer, but we're working on different work streams here for different industries. We're involved with a chemical production park in central Germany, where we're currently developing a solution for the new legislation for tertiary treatment. So we do have experience in this field, especially with industry.
Awesome, thank you. Matthias Williamson has sent through a question. He's watching live. How you will use ceramic materials for energy storage. So if you could just maybe comment on the use of ceramic materials for energy storage for Williamson.
Yes. In principle, there are these two options I already meant. So they can use the high temperature electrolysis to produce hydrogen and then do the re-electrification in the same system in the fuel cell mode. This is one option. And the other one are the sodium batteries to store these high temperature batteries to store electricity with these batteries. They are operated at about 300 degrees C. And so these are two options where ceramic materials can be used. And because these, in principle, the electrochemistry cells like batteries and also the solid oxide cells, they can easily be scaled. So also these energy storage is possible in different scales. So you can do it on a very small level. For example, also in principle, you can store energy for household applications, but also for industrial needs in larger scales, because you're doing the scale up by numbering up. So I see a lot of different applications for these technologies. For the electrolyzer, in principle, we are focusing more on larger scales. So what ThyssenKrupp Nucera wants to sell our systems in 100 megawatts and more. But in principle, for the fuel cell case, it's also possible to build small scale systems for 1 kilowatt or 10 kilowatt for different applications. So it's a wide range of wide power range what is possible.
Well, that was one of the questions, because you've been talking about, bigger like industrial applications, but one of the questions which came through was around, can this be applied in the household?
Yes, in principle, yes. But it's really also a question of not only of the technical solutions, what are possible, but also a question of the economics. What will be the best solution then for household application? And we also have developed a system for water treatment in this floating isolated solution. What we have developed in our institute is so a complete closed water system. So also there we have solutions there that can be used, but it's also every time a question of the economics. Then what is the best solution? So in principle, what we want to develop now we are focusing more on industrial solutions, but also smaller scale is possible. For example, in remote areas, you can use SOFC systems, for example, also with other fuels like ethanol to produce heat and electricity. This is also a possible solution, what we have developed also already in the scale of what I mentioned from 1 kilowatt. Also with this propane butane, you can produce electricity in the very small systems with 200 watt power range. It's also possible.
Thank you. So, Gregor, a question did come through with regards to if you could share at this stage, which I'm assuming not, if you're able to share some costed examples.
No, sorry, I'm not. We did have multiple projects in Australia so far, but they've been directly engaged with industry, and it's confidential. But we're currently developing multiple projects in Western Australia, and we will be publishing results as soon as possible to give a better insight into the applicability in Western Australia.
Paulo, I've got a question which has been sent through from Ralph. If I've pronounced that correctly, I hope I have. My apologies if I didn't get it right. But the question was, can ceramic technology help prevent polymer fouling in heat exchanger tubes, pipes, and reactors in chemical industries? And is it cost effective?
The answer is yes, absolutely. And even a combination of different filtration systems, it depends on what kind of problem you have and how that will be designed. So you can have a stage that will be based in ceramics, and then you have another one that could be with a different technology. But ceramics are very versatile, and you can also tailor the, let's say, the mesh, the size that you want. So you will filter exactly what you're looking for, the size of the molecules or the size of the particles, or with the type of particles you want to. So you can tailor that as well. And the fact that it's so resistant to different environments like high pH, low pH, high temperatures, it makes it a very interesting alternative for many of the problems that industry is facing. It might be on the beverage industry, could be in mining, could be in energy, it could be in water filtration systems. Temperature is not a problem, and ceramics are there too, of course, and has been classically used in many systems at high temperatures. So it's really a very elegant and very versatile solution. And if for any reason there was any change, any problem with the system, you can replace the ceramics pretty quickly and keep the system running for sure. Thank you.
Gregor, did you want to add to that?
Yes, one small detail. The current discussion feels like it's going in a direction where partners want to replace something they have with ceramics. And it is a good opportunity in many cases, but there's the possibility to rethink processes. If I may give one example from iron ore processing, we had a project where we had a very hot gaseous stream with iron ore like little particles of iron oxides, and the entire stream was quenched, and the particles then ended up in the liquid, in the water phase, and then we had to do water management. So we were contacted trying to improve the water management. What we very quickly saw is that they cooled down the stream quickly to do a filtration, but with ceramics you can do a filtration at 600 degrees if you want to. So what we did, we had a pre-quenching filtration where we got rid of most of the particles. We could then have a lower amount of water for the quenching, and we had a greatly simplified water management because we didn't have to get rid of all the particles from the slurry. We had fewer ions in it as well because they usually were extracted from the processed iron ore in the liquid phase, and it greatly simplified the entire process chain. At first, it sounded like it would make it more complex because we have an additional process step, but we could get rid of so many expensive process steps down the line that overall the process was more efficient and cost effective.
So Gregor, there was one more question which has come through from Hassan, who's watching live. He did pose it to the panel, but you are up there, so I'll give it to you to begin with. I was just wondering, with regards to the two major issues with SOEs at this stage, if you could comment upon that, being operational hours and cost.
Thanks, Megan. I'd start with cost. Cost driver for SOE at the moment is manufacture, because there's so few being built. Most of the steps are still being manual assembly, which drives cost. We see that in essentially any production environment, as soon as you scale up, the cost goes down significantly. As Matthias said, we are currently involved with ThyssenKrupp Nucera in establishing a larger scale production. And the estimates are that for a similar production capacity, we are in the same ballpark as a PEM electrolysis or alkaline electrolysis. But of course, they have a larger capacity at the moment, which we have to catch up on. In terms of limited operational hours, there's a bit of a misconception derived from alkaline electrolysis. Because in alkaline electrolysis, if the electrolyzer degrades over time, the voltage increases until you hit a voltage ceiling, and that's your end of life. For high temperature electrolysis, you have temperature to play with. So usually you start your beginning of life around 800 degrees. But if you increase temperature, the ohmic losses across your system decrease. So you end up with the same ohmic resistance overall. So you don't have just a voltage ceiling, but you have a temperature ceiling as well, which then extends your lifetime beyond what is usually shared. So this is not a property of the stack, but of the entire system. And if you keep this in mind, you end up with similar numbers that you can see from alkaline electrolysis as well. From PEM electrolysis, alkaline is still a bit better. But then you have to keep in mind that these processes are still manually built, and if you have a larger scale production with proper quality management, defects on the cell level will decrease, and this is the main degradation driver, and then you have a low degradation rate as well. So long story short, as soon as you have proper quality management and the proper strategy for running these electrolyzers, this will not be an issue or a downside compared to other technologies.
Awesome, thank you. Well, look, I think we've come to the end of our questions, so I'll pose maybe one final question to each of you. And really, it's just, I suppose, what you see as the key takeaways of the session today, or any final message that you would like to share with our engineering audience. I might start. I haven't given anyone any indication of who I'll start with, but Massimo, did you want to go first?
Megan, can you please repeat the question? I was a bit distracted.
No worries. So I suppose, final comments that you would like to leave with the audience, or
Okay.
key takeaway from today's session for the audience.
Okay, the key takeaway I would say is like there are huge opportunities in adopting ceramic technologies into Australian industry. Like this shared lab and joint collaboration with Fraunhofer is a huge opportunity for everyone to use and then use the hands-on experience of the Fraunhofer as well as the facilities and infrastructure in place at ECU to like test their real samples and see how it can be easily adopted to their industry, because that will significantly reduce the time of piloting when you test your own sample with the experts basically in the field. Yeah, thank you.
Thank you. And Gregor, your final comments.
I'd like to reiterate how great of a host ECU has been so far. For context, we've only had first contact a year ago, and it took us less than half a year to align all expectations. Seldom you meet someone that had such a complementary set of skills and expectations, and it was a very smooth process getting the joint lab set up. And yeah, just a year after first contact, we were already in the middle of building demonstration equipment and developing project, and it's been a great journey so far.
Excellent, thank you. And Matthias?
Yes, so first of all, thank you very much for the opportunity to take part here in this panel discussion. I've been 4 times to Australia, and what I really see is that there's a very high potential for renewables, for the energy transition. And if we can help by this transition with our technologies, that is what I'm very interested in, looking for new projects. And I see a lot of options also for exporting green products from Australia to Europe. Direct reduced iron ore, ammonia, green ammonia could be an interesting option for exporting. So I really look forward for new projects and to come again to Australia.
Wonderful. And Paolo?
Yeah, I think we are obsessed by impact. That's what we want. We want to achieve impact in everything we do. And we are not here trying to solve solutions for problems. We are trying to listen to problems that you may have. So come and talk to us. And if we think ceramics is not the solution because it might be too costly, because it might be something else, we will be the first one to tell you. But come and talk to us. And I think that's the main thing, the main message that you can take away. Maybe ceramics is the solution for a problem. Maybe it's some different ways that you can rethink the challenges you're facing. And we are here to talk. We like to talk. We like to listen. And if this is a solution, that's fine. But again, we are not trying to do any technology push. We are here with a lab that we will demonstrate how it works. We will talk about the challenges you're facing. And hopefully that's something we can work together and be part of a better company for you, a better process that you have to manage, maybe more costly effective than is today, more competitive in your sector. And then really see if we can transfer technology to small to medium enterprises here that can take this to the next level. I think that's what we are here for.
Awesome. Thank you. Well, that's all the time that we have for today. So please join me in once again thanking Dr. Matthias Jahn, Dr. Gregor Herz, Dr. Massimo Zaga, and Professor Paolo De Souza for their time and input. I'd also like to thank Engineers Australia's industry partner, ECU, for their support with the webinar today. Now, if I could also ask if you could complete the short feedback form, which is linked in the description box below. The feedback that you provide does help us to improve and plan future sessions for you. So finally, thank you again for joining us, and we hope to see you at our next Industry Partners event. Good afternoon.